Hello, everybody out there in computer land. Today we are here to learn about 5-8, radical equations and inequalities. And a radical equation or inequality is an equation or inequality where the variable is inside a radical. Now, it's very simple, okay, guys, because all we got to do is get rid of the radical. And remember that powers cancel out radicals. Okay, powers cancel out radicals. Now you may be thinking, what are you talking about? Well, let's think about it this way. If I have the square root of x and I square both sides, am I not going to be left with just x alone? What happened here is the power of 2 canceled out the square root. Why? Well, let's talk about it. The square root of x equals x to the 1/2. If I square that, remember that when you raise a power to a power, you multiply the exponents. So this would be x to the 2/2, which equals x to the 1, which is simply x. So radicals are canceled out by powers. If I have the cube root of 3x, I can raise that to the 3rd power, and again, the power cancels out the radical, and I would be left with 3x. So the main thing to remember here is that powers cancel out radicals. Now let's go through some examples and figure out how this works. For example 1, they want you to solve for x. And I have the square root of x plus 1 plus 2 equals 4. Now there's a lot of procedures that make things easier in math, and this is one of those procedural problems. First thing I always want to do is isolate the radical. So I want to get the radical alone. Now in this particular case, I have x plus 1 inside of the radical plus 2. So since I want to get the radical all by itself, I'm going to subtract 2 to both sides. That's going to leave me with square root of x plus 1 equals 2. Now I have the radical all by itself on one side. And now it's easy. How do we get rid of a radical again? That's right. We're going to square both sides. Now remember that you square both sides because whatever you do to one side of the equation, you must do to the other side of the equation. So this power of 2 cancels out that radical, and I got x plus 1 equals 4. Subtract 1 to both sides. X equals 3. Now, since we're dealing with radicals, I know it's a pain, but we have to check the answer. And we got to make sure that answer is valid and that it is real, unless they're looking for imaginary or complex number answers, solutions. If we're looking for real solutions, though, we need to check. If we're looking for complex numbers, we don't have to check so much. Okay, so in this particular case, let's check 3. If I have the square root of x, which is 3, plus 1 plus 2, does that equal 4? Well, this is the square root of 4 plus 2, does that equal 4? This is 2 plus 2, which equals 4, so it works. We checked it, we solved it, it works. X equals 3. That is the solution. Now sometimes, just like when we worked with the absolute value equations, we can go ahead and work with radicals with extraneous solutions. If you remember when we had the absolute value equations, we would check the answers for extraneous solutions. Well, let me explain to you how that works. Okay, example 2. They want you to solve the square root of x minus 15 equals 3 minus radical or square root of x. Now, I know that I told you the goal was to get the radical all by itself. Well, you have two radicals in this case. So in this case, we can't get either one of the radicals by themselves. So we're just going to go ahead and cancel out the square root or the radical. And we cancel out this square root by squaring both sides. Now, when you square the left side, the power of 2 cancels out the square root. So I got x minus 15 equals, now remember, 3 minus square root of x squared is 3 minus square root of x times 3 minus square root of x. So I have x minus 15 equals 9 minus 3 square root of x minus 3 square root of x plus x, because square root of x, negative square root of x times negative square root of x equals a positive square root of x squared. But since the squared cancels out the square root, you're left with x. So now I've got x minus 15 equals 9 minus 6 radical x plus x. Go ahead and notice that you have still a variable inside of a radical. So now that you only have one radical with a variable inside of it, let's go ahead and get that one alone. So I'm going to subtract x from both sides. So that cancels out my x's. Got negative 15 equals 9 minus 6 radical x. Go ahead and subtract 9 to both sides. So I've got negative 24 equals negative 6 radical x. Go ahead and divide by negative 6 because we're trying to get that radical's x alone. And we got 4 equals the square root of x. Go ahead and get rid of that radical by squaring both sides. The power of 2 cancels out the radical. 16 equals x. Now, let's check it and let's see if this works. Because if it doesn't work, then it's extraneous. So let's check. The square root of 16 minus 15 equals 3 minus the square root of 16. Let's see if that works. This is going to be the square root of 1, which is 1, which equals 3 minus 4. But 1 does not equal negative 1. So even though the solution is x equals 16, this would be extraneous because it does not work. So this would be an extraneous solution. Okay, it does not satisfy the original equation, so therefore it is extraneous. Now, we've been dealing with square roots. Let's see what happens when you have a cube root. Example 3. If I have 3 times 5n minus 1 to the 1/3 power minus 2 equals 0. For anyone that does not like working with fractions, you can turn this into a cube root. In other words, you can make this 3 times the cube root of 5n minus 1 to the first power minus 2 equals 0. So let's go ahead and add 2 to both sides. So we got 3 cube root of 5n minus 1 equals 2. Let's go ahead and divide that bad boy by 3, getting my radical all alone. 5n minus 1 equals 2/3. Then I'm going to go ahead this time and cube both sides. So I'm going to get 5n minus 1 equals 8 over 27. Okay? Now remember, I raised this to a third power, so the third power can cancel out the third root, okay? Or the cube root, sorry. So now let us continue. I'm going to add 1 to both sides of this equation. So I'm going to have 5n is equal to, well, this is 8/27 plus 1 over 1, which I'm going to convert to 27 over 27. So I can add this bad boy. So I've got 5n equals 35 over 27. Sorry, that should be a 27. Divided by 5. Divided by 5. N equals stay, change, flip. So n equals, you can get rid of this 5, cross divide, 7, and you'll have 7/27. Now, for this part right here, a lot of times people get confused on how the heck to do this. So when I have 5n equals 35 over 27, instead of dividing by 5, you could multiply it simply by the reciprocal. And if you multiply it by the reciprocal, you don't have to worry about the stay, change, flip, and you still are going to get 7/27. Now, let's check this. Let's check it. If we check it, we're going to plug in 7/27 into the original equation, and let's see what happens. So I've got 3 times 5n, which is 7/27, minus 1 to the 1/3 power minus 2 equals 0. Okay, this is 3 times 35/27 minus 1 minus 2 equals 0. This is 3 times, remember this becomes a 27 over 27. So this is 8/27 minus 2 equals 0. And 8/27, we can reduce that. Okay, or we can just cross divide, whatever makes your life easier. Because remember, this is to the 1/3. This is to the 1/3. So let's go ahead and say 3 to the cube root of 8/27 minus 2 equals 0. The cube root of 8 is 2. The cube root of 27 is 3 minus 2 equals 0. This 3 and this 3 cancel. 2 minus 2 equals 0. It works. So therefore, n equals 7/27 is the answer. It does work, and we're golden. Okay, so that's how you work with equations. Very simple. Now, the same procedures are going to work when you're working with radical inequalities. Same exact procedures. The only thing you have to be wary of is to remember that whenever you multiply or divide by a negative, you've got to flip the inequality sign. Whenever you multiply or divide by a negative, you got to flip the inequality sign. So let's look at the steps real quick. 1, find the possible roots. Find the possible x roots if the radical is even by setting it greater than or equal to 0. 2, solve the whole inequality algebraically. And 3, test your solutions. Okay, test your solutions. So let's see how this works. Let's look at example number 4. For example 4, they've got 2 plus square root of 4x minus 4 is less than or equal to 6. Now, since the radicand of a square root must be greater than or equal to 0, you got to first solve what's inside the radical. Or in other words, you have to solve for the radicand to identify the values of x for which the left side of the given inequality is defined. So let's think about this. We cannot have a negative value inside of here. So we got to pull that radicand out first and go 4x minus 4 must be greater than or equal to 0. So 4x is greater than or equal to 4. Divide by 4 to both sides. X is greater than or equal to 1. So we already know that x must be greater than or equal to 1. We have one of the possible solutions right now, right off the bat. We got to make sure that whatever radicand we're given, we set that greater than or equal to 0. Again, you take this radicand and you set it greater than or equal to 0, and that gives you one side already of the solution. Now, to solve the rest of it, just solve it like a normal radical equation. I have 2 plus the square root of 4x minus 4 is less than or equal to 6. I'm going to get that radical alone, so I'm going to subtract 2 to both sides. I've got the square root of 4x minus 4 is less than or equal to 4. I know that I'm going to get rid of that radical by squaring both sides. The power of 2 cancels out that radical, and I've got 4x minus 4 is less than or equal to 16. Add 4, sorry about that, minus 4 is less than or equal to 16. Add 4 to both sides. 4x is less than or equal to 20. Divide by 4, and x must be less than or equal to 5. So now we have two sides, both sides of the solution. So we know that x must be greater than or equal to 1, but less than or equal to 5. Okay? Now, we got to make sure that we're right. So we have to test again. Pick a value between 1 and 5. Let's say 2. Okay? If x equals 2, let's check it. Let's see if it works. If I have 2 plus the square root of 4x, which is 2, minus 4, is that going to be less than or equal to 6? Well, this is 2 plus 8 minus 4 is 4. So this is 2 plus 2, because the square root of 4 is 2. Is that less than 6? Well, I would say yes. 4 is less than or equal to 6. So if the solutions check out, then yes, my solution is valid. and it is that x is greater than or equal to 1, but less than or equal to 5. We could put that on a nice little graph. Here's my 0, here's my 1, here's my 5, closed circle, closed circle, less than 5, but greater than 1 is in this little interval right here. And that is how you solve radical equations and inequalities. Thank you very much, and have a great day.